Assalamualaikum and hi everyone, this is Dr. Shazira, and in this video I'm going to show you how to solve a system of a linear equation using Cholesky method. Alright, consider this problem, okay, and we know that before we start with the Cholesky, we need to make sure that our coefficient matrix A is a symmetric positive definite SPD matrix. Okay, once we have confirmed on that, then we can proceed with the Cholesky method. So for this example, if we take out the coefficient matrix A, it will be this. Okay, so now we need to ask, is this symmetry? Okay, and obviously this is not a symmetric matrix. Okay, so initially it is not. Okay, so what do we do to get a symmetry matrix? So we rearrange the rows, swap rows here and there. Okay, so that we can come out with a new A, which is symmetry. Okay, so you can see you may want to highlight the element that you only can see once. For example, we only have 1 of 45, and then 10, and then 4. Okay, so we can rearrange the rows, okay, so that we have something like this, so that it becomes symmetry. Okay, elements at the upper part, okay, in the opposite direction, okay, which means at the lower part they are actually, the same elements, the same values. So now we have new A in that form, but don't forget, if you change or if you swap the rows in A, B also need to be changed accordingly. Okay, so B follows 4, 6, 8. So 2, 4, and 11. So that is our new B. Alright, so now once we have the symmetry matrix A, then we can proceed with the positive definite. Proof A is positive definite. Okay, so we are going to prove the positive definite here by using the theorem. Okay, but you should know you can have proving by definition as well. Okay, but for this one, I'm going to use the theorem. So what do you need to fulfill is criteria number 1, the determinant of A must not equal to 0. So for this one, you can use your calculator straight away. So for this one, the determinant of A is 100. So clearly this is not 0. So we are okay with criteria number 1. Okay, criteria number 2 says that the main diagonal elements should be positive. So based on our matrix A, so we can see that A11, which is 4, so clearly this is positive. And then A22 is 10, also positive. And then A33 is 45. So all of them are positive. So we fulfill the criteria number 2. Okay, criteria number 3. Okay, so we want to see the maximum elements, okay, other than the diagonals. Okay, so based on your matrix A, okay, other than 4, 10, and 45, so we have 6, 8, and 14. Okay, we can see we have twice of each of the elements, 6, 8, and 14. Okay, and then we want to see whether the maximum out of these 3 is less or equal than the maximum, okay, among the elements on the diagonal. So on the diagonal we have 4, 10, and 45. Okay, so we are checking in terms of absolute value. Okay, so if you see at the right hand side here, left hand side here, so the maximum element in terms of absolute value is 14. And at the right hand side, the maximum element in terms of positive value is 45. So we can see that 14 is less than 45. So we are satisfying the condition number 3. So we are okay with criteria number 3. And criteria number 4, we need to check for every element that we have in A. We need to check whether we satisfies this criteria. For every I which is not equal to j, meaning that we are not checking for A11, A22, and A33. Okay, so meaning that we are checking each element here. Okay, but since we have a symmetry matrix, so you can choose the upper elements only, because it will be the same as in the lower element. All right, so take the first one. Okay, so this 6 here is at A1, 2. So it is equivalent to checking for A21, because they are basically the same. Okay, because of the symmetry behavior. So we want to see whether this is less than A11 times A22. Okay, so now in terms of value, so we have 6 square here at the left side. At the right hand side, we have A11, which is 4, and then A22 is 10. So clearly this is 36 is less than 40. So we are okay with that. Okay, and then next we want to check for A13. Okay, it is equal to checking for A31. So we do it together. Is it less than A11, A33? Okay, so A13 is 8. So we have 8 square here at the left, and at the right hand side it is 4. A11 times A33 is 45. Okay, so this is also satisfy this condition. Okay, so we are okay with that. And lastly, we have A23, which is equal to A32. Is it less than A22 times A33? Okay, so what is our A23? 14. Okay, it is equal to this guy here, which is A32. So 14 squared, 196. Okay, is it less than A22 is 10, and then A33 is 45. Okay, so less than 45 go clearly. So we are okay with that. Okay, so we can see that first of all, A is symmetry, and then we satisfies all of these 4 criteria. Okay, so we say that since we satisfy all conditions, all of the conditions, therefore A is an SPD matrix. A is a symmetric positive definite matrix. All right, so this is the first part of this problem. Show that matrix A is symmetric positive definite. Okay, now we want to see how Cholesky works. Okay, how do we get x1, x2, and x3 by the Cholesky? The Cholesky method. Step number 1. We solve for, we write A equals LU. Okay, and in this step we want to find the matrix A and matrix U. Okay, and then our matrix A, Okay, so write down one more time your matrix A, your new A, okay, this one, after you have rearranged everything. And then matrix L, okay, just a normal definition of lower triangular matrix. So we have A 0 0, B C 0, D E F. Okay, and another criteria for the Cholesky is the matrix U here, okay, is actually the transpose of L. Okay, this is specific for the Cholesky. So it means that for the U here, we need to transpose the matrix L. So it means we have A 0 0, B C 0, D E F. Okay, so that is our L times U. The multiplication of these two matrices here will gives you this matrix here. And then what do we do now? We compare both sides, okay, so that we can get all the unknowns at the right hand side. Okay, so compare both sides, position by position, element by element. So we can see that A squared, okay, at the left hand side, at the position of A squared is 4. So here we have A is positive or negative 2. Okay, but in a common practice, we take positive value. Okay, so I'm going to write here, take A equals 2. But anyway, you can take the negative, the negative square root anyway. Okay, but it is common to choose the positive one. Okay. And then next we have AB at the left hand side is equal to 6, and then from there we can get the B since we have our A. So B is 6 over 2, so we have 3. And then we have AD. AD at the left hand side is 8, and then we can get the D, okay, 8 over 2, so we have 4. Okay, and then what else? We have B square plus C square equals 10, and then from there we can get the C. Okay, so 10 minus B squared, and C is positive or negative 1. Okay, but again, the common practice is to take the positive square root. Okay, so we take C equals 1. Okay, just do manipulation here so that you can get the C. And then we have BD plus CE. So at the left hand side we have 14, and then rearrange the expression so that we can get the E. Okay, so 14 minus B times D over C. Okay, so we are supposed to get E equals 2, and lastly D square plus E square plus F square equals 45. Okay, and from there we can get our F. Okay, so F actually the square root of 25 here, but we take the positive ones, so F equals 5. Okay, so now we already know all the unknowns, okay, in the matrix L as well as in matrix U here. Alright, so that is step number 1. And then step number 2, we solve Ly equals B so that we can get our Y from that. Okay, so L, based on step number 1, we can rewrite our L, but now we already know the unknowns in L. So you put back all the A, B, C, D, and F. Okay, so we have 2, 0, 0, 3, 1, 0, 4, 2, 5. Okay, so this is actually A, 0, 0, B, C, 0, and so on at in the first step. Okay, and then we put our temporary unknown here, which is y1, y2, and y3 equals to the b. Okay, so b is the right hand side of our system, but don't forget, okay, we already change our b just now. So b, the new b is 2, 4, and 11. Okay, and now you can use your calculator to solve the three simultaneous equation here, or basically you can just do the manual calculation, okay, to get y1, y2, y3. Because at the first row here we simply see that 2y1 equals 2, so straight away you get your y1 here equals 1. And then from the second row we have 3y1 plus y2 equals 4. So from there we can get our y2, just manipulate the expression. Y2 is also 1, and y3 can be obtained by the third row. Okay, so y3 is also 1. Okay, I hope that one is not that hard for you, okay, to get all the values of y. And our last step in a Cholesky is to solve the expression ux equals y. Okay, so now we can get our x. Okay, so similarly, u is the transpose of L. So what do we have? The row in L will be column in u. Okay, so we have 2, 0, 0, 3, 1, 0, 4, 2, and 5. Okay, and then we multiply with our unknowns, x1, x2, x3, which is equal to our y, 1, 1, and 1. Okay, so again, solve the three simultaneous equation manually or by calculator. So for this one, we are supposed to get x1 is negative 4 over 5. Okay, x2 equals 3 over 5, and then x3 equals 1 over 5. Okay, so basically you just simply solve from here. Okay, you start with the row number 3 first. Okay, because we can see from the third row here, we have 5x3 equals 1. So that's why x3 equals 1 over 5. Okay, and then you go to the second row and then the first row. Okay, so we are supposed to get this answer. Alright, so that's basically the Cholesky. So what you need to remember, first of all, in order for us to use the Cholesky, matrix A must be symmetry and positive definite. If it is not initially, then try to rearrange so that you have a symmetry matrix of A, and then after that, try to prove, check whether A is positive definite. Okay, after we have confirmed on the SPD matrix, then the Cholesky method follows the normal procedure of LU method. Okay, the first one, A equals LU, but again, another specific criteria for the Cholesky is at U here, which is the transpose of L. Okay, other than that, you just follow the normal procedure in LU method. Okay, start with the A equals LU. Second step is LY equals B, and then UX equals Y. Alright, so that is Cholesky method. So I hope this one is clear to you. Okay, so see you in the next video. Bye bye. Thank you.